Good morning to all participants. We would like to welcome you all to the webinar series conducted by Department of Computer Science and Engineering, Siddhaganga Institute of Technology. Today's webinar series is on new trends in communication. And we would glad to have a speaker with us, Mr. Ramayya Subramanian. He is an advisor and former vice president at Hughes Communication India Limited. It's glad for us to have Mr. Ramayya Subramanian here with us. He is a satellite communication technology specialist with business experience over 30 years with ISRO and Hughes. He is retired as assistant vice president, government sales and business development with Hughes over last 16 years in various business roles for the company with a dedicated sales and operations team. Currently, he is working as advisor sales for Hughes India. He is a SATCOM technocrat, VSAT and satellite services using bent pipe and high throughput satellite communication GSAT 191120. He is involved in design and he rolled out complex business development programs and large-scale high technology-driven projects. Earth station solutions and he handled projects in various brands like C, Q, K, CS, L, etc. His key career achievements are he designed, implemented, and successfully supported real-time satellite communication data over voice network for IRS, PSLV, GSLV missions for ISRO docs. Realization of S-band TTC stations as part of India launch or satellite missions like IRS, PSLV, INSAT, and GSLV for Instrac ISRO. The instrumental in bringing first Q-band commercial VSAT services in India by hiring first foreign Q satellite through Antrix, ISRO, DOS, as well as establishing the hub system for Hughes, which benefited across the country and industry. As part of sub-technical subcommittee with DOT, ISRO DOS, NOCC, and WPC authorities got the VSAT antenna sizes reduced in C, XC, and Q bands for India, which benefited across the industry. EduSat VSATs plays important role in BharatNet NOFN2 as part of Digital India with BBNL or BSNL projects. He developed, won, and executed major government system integration projects for Hughes like EduSat, BSNL, ICNS, BharatNet, etc. It's a proud and privilege for all of us to have you here with us, sir. Over to you, sir. Can share the screen. Are you able to share the screen, sir?
Yeah, are you able to hear me? Are you able to hear me? Hello?
Yeah. Yes, yeah, we are able to hear you.
And my slides are getting shared now. Are you able to view my slides?
Yes, sir. 1 second. Screen.
Name the stop sharing one. Wait a minute. Oh, yeah, it's on.
Is it fine? Are you able to see the slides? Are you able to see my slides?
Can you share the screen, sir?
Yeah, I have shared the screen.
Sir, can you hear me?
Yeah, I'm able to hear you. Again, I'll share the screen. 1 second.
ಅದನ್ನ ಮಾಡೋಣ ಅವ್ರು ಅಲ್ಲಿ ಶೇರ್ ಮಾಡ್ಬೇಕು ಇನ್ನೂ ಬಂದಿದೆ
Sir, can you share the desktop?
No, I'm sharing it now. You see, are you able to see?
ಅಷ್ಟೇ ಈಗ
Yes, we are able to see your screen, sir.
Okay.
ಸ್ಟಾರ್ಟ್
You can start the session now, sir.
Yeah, now let me go back to the PPT.
ಬರುತ್ತೆ ಸರ್ ಯು ಕ್ಯಾನ್
Sir,
ಸ್ಟಾರ್ಟ್
you can start the session, sir.
Yeah. Are you able to see the screen?
No, sir. Still,
Yeah.
earlier it was, now it has gone. Will you share it again? Yes. Yes, sir. We are able to now. Yes, sir. Good to go.
Okay.
Yeah.
So, friends, it is nice to have all of you, and I am really happy that a good number of students and faculty are interested to know more about satellite communication. If you all recall, telecom is something which keeps evolving over the years, and nobody would have expected at any point of time the cellular will get into such a major instrument in the common man. Similarly, satellite, which is existing for more than 50 to 60 years now, slowly becoming a sort of reaching into the numbers where it will be available for consumers. Till today, the satellite is basically for enterprise customers as well as for video broadcasting applications, etc. So, in that way, the satellite was majoritarily used as a business communication requirement rather than getting into a sort of consumer utilization of equipment. The another thing with satellite communication is it is mix of two different technologies specifically. One is, yes, it has to have the telecom domain because it is basically a computer networking, data transmission, and video transmission, etc., etc. The other one is the media. Media is not simple media like fiber where you connect through a cable, you reach at the other end. Whereas satellite, it involves space, which is reasonably unknown element and behavior, and an instrument which is put 10 to 15 years back into the space, its behavior, etc., becomes very crucial. That way, the domain expertise required for satellite communication is very huge. And fortunately, unfortunately, India has a reasonable people because of ISRO growth. However, because the private sector is not into it, we are unable to get that sort of numbers with respect to volumes. So to start with, I little talk about my company, not much, so that you know where we stand. Hughes is one of the major VSAT equipment manufacturer, satellite manufacturer across the globe. There are very few players, VSAT and satellite technology being niche market, but Hughes is number one into it, and we are there more than 30 years, and the first VSAT was operated by our chairman, who still is available to us to guide, and he is basically an Indian. That is what is very important for all of us to know. That made him to invest in India more than 25 years before, and we continue to enjoy the benefit of VSAT technology. Yes. The slide is not changing.
Share the screen, sir. You can just press the cursor.
Okay, I shared it. Down also it is not there.
Yeah.
No, do I need to make this? No, I think I'm not able to change the slide.
Next slide. Go to next slide.
No, right click చేసి next slide రా.
Shall I can't make this? 1 second.
ಸ್ಟ್ರೀಮ್ ಯಾರು ಚೇಂಜ್ ಮಾಡ್ತಿದ್ದಾರೆ ಅನ್ಸುತ್ತೆ
Yeah, now I got it. Okay.
Yeah.
Right. Yeah. I think it takes some time. Oh, yes. So if you look at global trend, whatever I explained in the previous slide, the enterprise business for VSAT was growing from long time, whereas the consumer market slowly started. What is consumer market basically? The consumer market is like you have a mobile, you do your hotspot and start using the any of the nearby instruments like that. So the consumer, an individual consumer should have the instrument at his disposal to use as a connectivity for any media he wants. That's what looks to be the big thing which is happening today. And you see slowly the volumes are growing from the above chart. So that is one part of it. Again, little understand about basic satellite system because I want to put everybody onto the part so that somebody knows little more, somebody may not know much, and it will be difficult for any of you to follow the further slides. It is like say, all of us are very clear about cell towers, right? BTS we know signal illa, we don't have tower, etc. It is similar to having a cell tower in the sky, but the system evolved over the years. Today we see the cell tower receive signal and transmit back our instrument. Whereas in satellite, there were satellite which was like a mirror. It receives signals from the ground, it transmits back. Then it receives signals from one place, transmits back a different place. Then it receives signals from one place, transmits back to specific state, specific geography, specific footprint which you are interested. Then the satellite came, which started accepting signal from one place and then do some sort of IP maneuvering, like take the IP address, put it to the specific instrument at that specific location, identify the location, go for it. So these type of evolution. So we are going to talk much about this. So we will explain those things again. And what makes satellite different from rest of the telecom media, communication media? If you carefully see any of our traffic consumption or any of the requirement for telecom is to have higher download of data and smaller upload of data. So that is asymmetric data we call. Symmetric is equal, asymmetric is unequal. So when you start transmitting asymmetric data, any of the media other than satellite will have to waste one side of the capacity that cannot be fully utilized. Whereas in satellite, you can fine tune them. Even when you launch a satellite, you can always try to say the one stream will be always having higher capacity than the lower capacity from the user side. So that way, this is unique facility is possible only through satellite, no other media. Even radio, you call any other media, is not possible. One more advantage you have is you can identify the location where you want to transmit. You need not hog the complete chain or complete channel or complete infrastructure to do one multicast. For example, Prime Minister address, you want to do only to a specific state. That is possible with the satellite. Nowadays, of course, multicasting, there are some possibilities coming up with fiber, but that needs a lot of settings, etc., etc. So that multicast of identified locations is possible. Very major advantage people see with satellite is you will have complete control over the traffic what is being transmitted. For example, some sites which you do not want to go on live is very easy in satellite. You will be able to block those sites in no time across the, and also you will have a record of those HTTP addresses, etc. So what I want to differentiate is, pager was there for many years. Overnight pager was killed by cellular. So the technology should evolve itself to the business needs and changing times. That is very much possible with the satellite, and that's how the satellite continue to exist over the years. So the major advantage, if you sum up at this point of time, asymmetric data and completely safe network, and you'll be able to do selective multicast, and also you'll be able to do huge data downloads. Very major advantage, again, one more point is the channel. The channel of 1 GB, 2 GB, whatever you call, can be allocated to a single customer for a fraction of a second, and that channel can be removed from him and can be dynamically allocated to another required user. That is called dynamic allocation of bandwidth, which normally no other media is possible. You lay a fiber from BSNL exchange to my house. If I am logged for my house for next 1 month, this bandwidth gets wasted. Whereas in satellite, it's not like that. So somebody doesn't have any, for example, even somebody types a mail. During his mail typing, no bandwidth will get allocated. Whereas when he immediately does a file transfer, the complete bandwidth available in the channel is allocated to him. The file transfer happens at very faster rate and then gets completed and channel gets free to the second user. These are all a few basics about satellite. Now let us look at how the applications are there worldwide. The satellite is being used in spite of having excellent wired connectivity across the country. You look at US. US has got an excellent wired connectivity. There, if you see my earlier slide, you will see the maximum consumer broadband through satellite is only on satellite. So because people are isolated, they want their privacy, their houses are different locations, etc. Which is similar to our rural area. Our rural area has smaller clusters, right? So that's why many of these applications, around 12, 13 applications I've listed, around 6, 7 applications we are into it. India is into it. Whereas the other 6, 7 applications, we are yet to open up, yet to see the growth, yet to make the thing like that. One more, if I just read out, you see IoT connectivity and connected cars. What do you need? You need a complete, reliable connectivity without interruption. Can a connected car be linked without 2 seconds or 2 minutes? It is not possible. But the satellite will give you the reliability and complete coverage is possible. So these type of IoT, connected car, etc. applications are getting tested. Our own company has tied up with the automobile manufacturers like General Motors, etc. Pilots are on. So they're not much far. I mean, definitely those things will come up at very short time. Similarly, aeronautical broadband, which we call it as IFC, if people flying between Europe and US, they will see they get connectivity on the plane, which no other media can use, the satellite use it. So those applications we are yet to implement in India. Doesn't matter, India is definitely now opened up. I think you will see some more slides on this, which will give you a clear picture about where we stand. Also, there are key satellite elements which we will have to understand little bit. Space segment, basically talking about variety of satellites, different orbits, frequency bands, location of the satellite, how far from the ground segment, etc. The second element is ground segment. That any satellite needs a gateway, basically we call a major ground segment where it reflects, it communicates back all the traffic and as a single point of location. Yes, there is a single point of failure on this, but the gateway has to be maintained, redundant, power, etc., etc. So the VSAT user terminal is a user location where I can have a VSAT anywhere I want, I can carry wherever I want, and that is the type of. So let us understand these 3 parts. I'm not going to much explain about ground segment because that is more of electronics and equipments, etc. I will more explain to you about space segment and as well as VSAT terminals. Yeah. If you see, the spectrum and orbit are very scarce resources. I don't think any Indian need to be told about spectrum, how important it is. But at the same time, the spectrum is one thing which you don't use, and that day that spectrum usage is gone. If you use it effectively, you are able to use it better. So again, in satellite, the spectrum is used as and when required. If you don't use it, it gets lost. So we have a lot of spectrum which is unutilized, and those spectrums we will have to find the ways and means of utilizing it, which other than cellular, we are not using much of the spectrum like other countries are using it. So that is one thing. And the second thing is, spectrum is something where anybody can radiate any signal, put a small transmitter and he can spoil the whole spectrum and he can corrupt. So for that purpose, there are some agreed rules across the globe where that is as usual, United Nations body, ITU, where there is a spectrum allocation happens. Majority they say, over this band use it for this purpose, this band use it for this purpose. Again, within that band, whether we agree, we don't agree, is left to the respective countries. So that way it becomes very difficult to manage. Why? Because US may use some spectrum for the satellite communication or mobile communication. India say, no, I don't want to use it, I want to use it for cellular. So the equipment development, equipment integration, cross connect, etc., will be difficult. So it is definitely very difficult thing for us to do it. Similarly, orbit. Satellite has to be put at different location on the space. Now everybody wants to put, for example, you look at our own India, Pakistan wants to put, Sri Lanka wants to put, Arab country wants to put, India wants to put. But all of us will have the visibility or the coverage or footprint only from the same location as nearby location. So these need to be controlled. So the ITU becomes very important for us. That's why it has been, ITU has made it fixed satellite, maritime, aeronautical, mobile, broadcasting, amateur, experimental purposes, and satellite is specifically identified a spectrum. So if you see mobile, cellular always needs more and more bandwidth. But we have to understand, is it only cellular is required in the country? There are so many locations which cellular phone cannot reach. So we need to have the other things like broadcasting. We are talking about Doordarshan transmitting on terrestrial links, and aeronautical, the flight has to communicate through the same spectrum to its ground controller. So that is becomes important. When somebody is on the sea, he has to communicate. So this purpose, ITU has made these distinctions and allocated bands. Unlike in 1, 2, 3, 4 or ABCD, there is a reason for calling all these spectrum bands with respect to their frequency by a nomenclature. The lowest is L, the highest is Q and V as on date. So normally the satellite commanding happens. Satellite has to receive commands. In that frequency, nobody else should transmit. So that happens in S band. C band was normally connected between continents from Europe to Asia, US to Europe. So those band normally called C. But India tweaked that little bit, called that C as extended C, and then started using it within India. That point of time, ISRO did not have the expertise on KU, so the C band was crowded. So they started using extended C. That's okay. Now those VSATs are slowly going out of scene. Then the KU. The KU came. Then the big expansion came, and we Hughes as a private operator. First hub we have put it in KU, and today the KU continues. More than 20 years now, the KU is a workhorse of satellite communication in India. Next came KA. I think K is wrong. KA. The KA basically is higher than KU, but it is now very popular across all other countries. We are yet to launch KA satellite. However, ISRO will not be able to jump in one go. So they are doing KU bar KA, that one segment KA and one segment KU. Having said that, it's not that is a limiting factor alone. We have many other limiting factors. Whereas Q and V above 50 gigahertz, you see those frequencies never being used today by anybody. Neither you call cellular nor you call satellite. So that means that band, there is a potential of using it, which we are not able to use, basically because we don't have the equipment, we don't have the volume, we don't have more people getting into that band. So people are not able to make efficient way of utilizing. So these things are being now discussed. How we move from existing KU to KA for India, and foreign countries are looking from KA to Q and V. Hughes being equipment provider does all bands of equipment. That is an advantage with Hughes. Now, this I explained to you. C band is fixed satellite service. KU band is DTH. All of you are aware. All our Indian operators use KU band for DTH. KA band, ISRO is going to come up. Hughes has put up a requirement also for KA for our own satellite. I'll explain again. Q and V band is 40 and 50 gigahertz, which is yet to take up in a big way. Yes, this is little explaining what it means, the application, which I don't think you need. I think I have sufficiently explained. One important thing you note down is mobile satellite service. This is very important. Mobile satellite service, you can't use KA or KU because they are all pointed signals where you need a directional antenna, etc. But having said that, KU also the flat antenna has come. We will again discuss. Mobile satellite service, like a handheld instrument, people call satellite phone. You might have heard it in news, no? Terrorists use a satellite phone. So like that. So that satellite phone is very small phone, directly communicates to satellite. That is required in L band because that L band is probably lesser of attenuation compared to the higher bands. Okay. Yes. Now the new band of our interest is KU and KA. KU, ISRO has done sufficient satellites. World is today working on KU. Every terminal volumes are made in KU band. And terminals have become very cheap. I won't believe you just go and buy one, fiber modem like home. You buy 3,000 rupees, right? 2, 3. I don't think anybody, even dealing, does not sell you less than 5,000 rupees if it is a good modem. where you will have a Wi-Fi connectivity at your home through the fiber link. These modems are not much cost, let's say 1.5 times more than that or something, where these satellite modems are directly connected to the satellite. Basically because of volume. The volume is so high and everyone is into that Ku band, so it is giving the cost advantage. Ka, we have a bigger spectrum available, so these spectrums are getting full more on, I told you, with spectrum as well as slots or scary resources. So once it gets full, you have to jump to next spectrum or find a new technology. The advantage of satellite is keeps on evolving. Yes, we'll talk about little bit about orbits. Again, what is orbit? Satellite is an artificial element which you go and throw in the space, and it is expected to follow a routine path or a track during any point of time. So now, as per the astronomy, if you throw any piece at 36,000 kilometers away, it is expected that your local time and the satellite local time will be the same. That means satellite will be always visible to you at any given point of time at specific azimuth elevation. What is azimuth elevation? Azimuth is x-axis, y-axis is elevation. You assume blindly like that. So with that, it's always available to you at that point of time, 36,000 kilometers away. So any antenna you put on the ground need not be turned, oriented, changed. Fix it once it gets fixed. Having said that, what happens to the satellite? Satellite will have drag, atmospheric drag, other drag, etc. And it will start slowly losing out from its location where you left it. Then satellite operators fire some thrusters. Now electric propulsion has come. With that, they retain the satellite at the same spot. So that's what they do. So I think that story, let us not take it up now. So if you leave the satellite at 36,000 kilometers away, you expect the satellite to be available for you all the time. That is called geostationary or geosynchronous satellite. Geostationary, geosynchronous is small difference. That's okay. So then comes to medium earth orbit. Medium earth orbit is mostly a circular satellites where you don't need to go so far. Around 500 kilometers onwards, you will be able to do it. And it can have a different inclination with respect to equator. Okay, so it can be polar orbit, it can be geosynchronous orbit, any orbit. Sorry, not geosynchronous. It can be elliptical, not elliptical, round orbit, circular orbit. So that is called medium earth orbit. I'm just explaining to you, it's not much important to us because unfortunately only one project came with medium earth orbit satellite, and that is still working, but it is not a big success. So the investments are not coming into that segment. So probably I will not dwell much upon it. Whereas our major interest is on low earth orbit. It's really astonishing what is happening in last 1.5 years. Low earth orbit is taking up many companies, many technical solutions, including an Indian startup. Please understand, it is not that we in that way we are back. Including an Indian startup has put up proposals for low earth orbit satellite, which somewhere around 330 kilometers to up to 1,200 kilometers also. So these satellites, the major advantage is they are very close, no doubt, but the disadvantage is they can't be available to you all the time because approximately 90 minutes once it rotates. That means you get signal, say if you take some 45-degree elevation, so somewhere around 45 minutes or 50 minutes you will have one satellite. Once you have a 3 hours video conference call, then after 45 minutes you are expected to switch over to another satellite. That was a challenge technically few years before. No more now. Let us see more about it. So this is just gives you an explanation. If you see the number of hours, that means it takes satellite to rotate. You take 24 hours. A satellite at geostationary 36,000 kilometers away also takes 24 hours. So more and more lower the height, it takes lesser time. So when it takes lesser time, you have the challenge of visibility for you, which is your interest. See this, how surprising. This is also old. I don't say it is as of latest. You have slots available. It is like 360 degree, right? You can't create 360 cannot become 3,600. So this 360 degree around you will have to place the satellites, and every country wants to place the satellite. But at the same time, you should not interfere with each other. Everybody will focus towards the earth. So everybody wants the visibility, everybody wants their better coverage, and the power needed for every satellite operator towards the ground is going to be very high, etc. So to really control this, there is a lot of working going on. There is a complete big group which is doing it in UN as well as in every country. So this is how it looks like. A small note on this is, earlier it used to be 3 degree separation between one satellite to the other. Now they will reduce it to 1.5 degree. Why? Because the ground segments have become more and more controlled, and you are able to get better performance. And our on axis is further, beam width are further getting lowered. I think communication people will understand what is side loop. The side loop levels are getting reduced, etc., etc. So with all that happening, we are able to accommodate more and more satellites. Also, you are able to do the satellites at different frequencies. Somebody uses Ka, somebody uses L band, somebody uses K band, somebody uses C band. Then you in the same slot, you will be able to put more satellites, but the slot remains the same, right? And another beautiful thing in this is, as for ITU, you go and put the satellite early, you are assured. You sleep for 10 years, you don't put this satellite in that slot, your slot gone. So somebody else can put it. So India is able to put few satellites. I won't say we have done the best. Reasonably, we blocked some slots. But now, when we are growing, when we want more slots, we are unable to get those slots. Then we go to the higher band. So this is a big game. Yes, let me understand about that. Now let us come back to the ground. From satellite, how the satellite footprints looks like. Technically, as a paper, if you say 3 satellites, you put at 120 degree separation, you'll be able to see the globe across sea, land, everybody, and connect anywhere to anywhere. That is theory. But getting the coverage of such an area, having power of equal power across those locations, etc., challenges. So, and also it's unwarranted, because it's highly regulated environment, and hence what they try to do is they try to take satellites geographical requirement. For example, USA goes only for their requirement. Europe goes only for their requirement. So that becomes hemispherical beams. And some satellite operators, they want to connect continents, like Intelsat, which was a conglomeration of many countries. They started getting satellites covering 2 continents, etc., etc. So that is one. So if you see here, hemispherical beam, then the regional beam, which you understood. The new thing is spot beam. Spot beam, in the sense, instead of spending whole power and frequency and interfering across the unwanted location, you transmit only Karnataka, for example. Take a Karnataka map, do the beam shaping with the antenna, and focus only on Karnataka. That becomes a spot beam. Now the spot beam has become very, very successful, and lot of development is happening on spot beam. And India has done an excellent job on the spot beam, which you will see also. Of course, definitely other countries also. Now, the new term I am introducing, HTS. HTS is called high throughput satellite. I was now explaining to you the frequency and beams. Now I am going to talk about the satellite. The satellites are basically a heavy weight carried from Earth and left into the space, consisting of simple receiver, mixer, local oscillator, amplifier, antenna. Okay, if you consider like that, it is simple like any other electronics equipment. Now that equipment needs power, that equipment needs the AC controller, temperature control, and the location of the satellite has to be specifically looking towards Karnataka, it should not look Tamil Nadu. All that beam forming and location, arresting the satellite, those things have become a bigger job. So the with all that ancillary things, the payload, what you put it, the actual utilization of the satellite earlier used to be very less. So they are not able to carry more transponders, we call transponders, which reflects the signals from Earth to ground. We are not able to carry more transponders. Now the new technology with this beam shaping coming, and satellite becomes more heavy and powerful. The satellite launch vehicles are able to carry heavy satellites. The HTS award. HTS, today we have HTS which is capable of doing 200 Gbps. If I now consider a 2-ton satellite, what we used to have, or what is still operational under ISRO, may not be able to give you more than 15 GB. Because each transponder cannot give more than, say, 40 MB or 50 MB, like that. So the HTS has become very, very cost effective because the amount of money you spend for launch and building a satellite is similar. Maybe slightly the order of magnitude higher, but the output what you get from them is very high. So HTS is able to give a higher spot beams, higher number of throughput and the spot beam. Now the spot beams, how do you overlap? It's like similar or a mobile cellular. You have a circle 1, circle 2 will have different frequency, circle 3. So the overlap. I think this is very simple. Anybody will understand this beam separation, right? Yeah. So look at this. Now again, I'll go back. The beams. One is wide beam, which covers whole India. ISRO used to launch plenty of satellites on wide beam. We have become expertise on wide beam. Multi-beam satellite. You all remember VTU was using one satellite called EduSat. What VTU transmits will not be visible to Northeast. What Delhi University transmits will not be visible to Karnataka, like that. So that is called first experiment of ISRO for spot beam, whereas spot beam satellite worldwide has come plenty. Now also ISRO has come out with spot beam satellite. I'll come back to that. So those spot beam satellites is another thing with HTS, higher capacity it has come. And the third element is I talked to you about LEOs. Non-geo generally, but non-geo includes LEO and circular orbit, MEO. Okay, but MEO as we are not really looking at much. But a little difference between the orbit, but in terms of the utilize, I think I'll go back to this slide. Yeah, so this just gives you HTS which are in orbit. You just imagine how many HTS you are able to see across the globe. This was again old slide. So if I now take up new data, it will be very, very high. Look at 5 Gbps, 16 Gbps, and 6 Gbps. I mean, lot. If you see only one, I'll be able, I don't know whether I'll be able to show it. I think, yeah. So this is the INSAT 11, 74 degree. This is like ISRO approved, ISRO owned, ISRO has priority, etc., where India can do anything. They have launched the first GSAT on spot beam satellite, GSAT 11, which is working very well. It is KUKA. Having said that, almost 10 to 15 years, 12 years before, not 15 is too much, 12 years before, you see here, Thaicom IP Star was used by BSNL, which is also a spot beam satellite, which gives 45 Gbps. But unfortunately, the ground segment, what was supplied along with that was very, very old equipment, and they are not able to get the speeds. Whereas recently, we got into it, we used the satellite full its capacity, and we have shown to government 110 Mbps download on a single laptop through a VSAT, and it's able to upload 10 to 15 Mbps. See, this you should always look at fiber differently and satellite differently. Satellite getting 110 Mbps is first time in India. So we have shown that, and BSNL is now doing it for many of the things. Yes, I mean, I was always mentioning about ISRO, so I thought I'll just make some small comparisons or how we evolved. ISRO first satellite came at 83. Now the recent one is we have 3 satellites operational with spot beam. GSAT 19, 29, and 11. Okay, all the 3 have good capacity. 11 has got around 40 Gbps. 29 is around 14, 15 Gbps, and 19 is around 14, 15 Gbps. Basically, 19 and 29 are experimental satellite because launch vehicle they wanted to test. 11 was a proper professional satellite, close to 5-ton satellite. So 11 is being operational. So slowly we are entering into spot beam with KU band. Just for history, current operational satellite, if you see, so many satellites are there. If you see the nomenclature, I have used some of the things are like bent pipe. What is bent pipe? Simply receive the signal, mix it with the local LO oscillator, amplify it, put it to the antenna, transmit at different frequency so that there is no frequency decline. That is called bent pipe. Now, the STS last one, Thaicom, I have put foreign satellite, and the GSAT 11 is also there as STS. I have written 2919 STS. Okay. So I hope that this clarifies about the Indian satellites, 31, all that bent pipe satellite. Now, on STS, what is our plan? ISRO is looking for launching GSAT 20, which is around 50 GB capacity. I mean, with Corona, all that, it got delayed, and otherwise by now it should have been in orbit. Hopefully, 21 first quarter, if we go, we are very happy, but doubtful. So what is special about, that is some history. Now understand how HTS works. HTS has got different input and different output. For example, it picks up from locations. In this case, if you see, it can pick up from Ahmedabad and transmit only in the west. And it can pick up from Ranchi and transmit only northeast, Jharkhand, West Bengal, etc. So that means it takes signal from that one location, whichever identified locations are within the beam, then puts it back. What is the time? Puts it back into the specific spot beam which it has been identified. Okay, so this is the character of it. Here we have, in the satellite, if you see how beautifully the beam shape got done to meet only the India requirement, and we don't spill the power in the other location, and anybody wants to transmit that, they will not get the signal, etc. Okay, the core
11:37.
Oh. So the core issue here is the hub. The hub has to be very well designed. There should be a backup, because hub fails, the complete beam fails. So hub has to be very well designed. And major thing is hub is Ka band. First time for India. So Ka band is first time. We will have to establish so many hubs, and ISRO has put their own capital and installed it. All four are working. One in Bangalore. Surprisingly, if you come and see, in Bangalore, BSNL, we have a Ka band hub. So it transmits across Lakshadweep, Tamil Nadu, Kerala, Karnataka, etc. So another point, again, you note in this diagram is transmission is Ka band, reception is Ku band. All the VSATs will receive Ku and transmit Ku. They don't, because we don't want to complicate the remotes, because remotes are big in numbers. Hubs are very small in number. So hub you can complicate, make Ka band hubs and Ku band remotes. And Ka band hubs, the challenge is there will be a cloud attenuation. Ku band, there will be rain attenuation. All of you are aware. Male bandre cinema nodakagalla, TV nodakagalla. Finish. So in Ka band, you will have the similar problem with the cloud attenuation. However, being the few locations, 4 locations, 3 locations, we will be always able to have power amplifiers higher, pump more power as and when you see the rain. So this is also another technology. Nobody will know when it will rain. Nobody will know what is the strength of the rain. Similarly, nobody can say how much cloud will come, how much signal will get attenuated. So the satellite signal, unless you reach satellite crossing this cloud attenuation, you will not be able to pump it back. So this is also a big technology called uplink rain attenuation, and we have rain margins. It's a lot of involved calculation. Unless you plan all those things and put the ground segment and the satellite once it goes to orbit, nothing can be used. So this is the major challenge. We did an experiment well before 2000. I was part of it. We did an experiment how the rain attenuation on Ku band will behave. We margined it. We ensured that those values are put in, and now it has become very easy. Similar exercise we in the process for Ka band. This is GSAT 20. As per IC, I don't see any much difference between 11 and 20, other than VSATs are also Ka. That is one challenge. But the VSAT dimension, antenna dimension, is going to be smaller for Ka. There are regulatory issues, etc., which we will discuss. But otherwise, the advantage what we are going to see is, now all of the petrol bunks and ATMs, sometimes you see the dish. The dish size looks little big umbrella. Instead of big umbrella, you will get a smaller umbrella. Okay, but still we need that dish. What are the various applications on VSAT in India? I think I'll stop after 2-3 slides about India and then jump into other location. International scenario. We have around 3 lakhs VSATs. Basically, it is not big if somebody compares with mobile. But mobile, as I told you, it is consumer business. It is an enterprise business. So that way it is different. And DTH services, ISRO has got so many transponders leased out. And DTH is very popular for us. And satellite services are being used. Bank ATMs, many places. I can say around 60% of the ATMs are only on VSATs. Why? Because the reliable connectivity and controlled environment. No security breach, nothing will happen on the connectivity. And they can address, they can upload, many things they can do through the dish. So the recent one is oil and gas, all petrol pumps are getting connected, because the rate revision has to happen every day. Petrol price has to be changed, and that day morning. So that's another thing. And BharatNet has come out with a bigger project. I think these are all a little application. I think I'll go a little faster. So MEO constellation, I told you, it is like only one satellite, major operator has put in satellite called O3B. But unfortunately, if you really see, the satellite antenna needs to track the satellite, because satellite is not going to be available 24/7, right? So it is going to drift. When it starts drifting, the second satellite will come. So some antenna at the ground has to track the satellite from lower elevation, come back to the peak, and again go to the higher elevation. So that means the antenna tracking system at every location required. You can do any jugaad at the central location. But if you get into remotes, complicating it, the project will fail. That's how it has happened. The moment you wanted the remote locations to track the antenna, it became very costly affair. So they were not able to really try to get that type of speeds. But however, you put a bigger antenna, you always get a bigger data rate. So higher data rates were possible. Yes, now the interesting part is about the Leo constellation. So Leo constellations, if you see what we gain, earlier we were 36,000 kilometers away. Now we are somewhere around 400, maximum of 800. Somebody is going up to 1,200 kilometers from there. So more closer you come, the time delay, I mean all microwave, you know, the time of lambda, right? 70 lambda by 2 or some. So these formulas, if you see, I forgot. So Leo, the time which takes between satellite to the earth starts coming down. If it is 36,000 kilometer geostationary, then it needs 600 milliseconds one way. You have to go and come back. So here it becomes 50 milliseconds. So that any application where you are interested, 275, 600 milliseconds. So any Leo application, wherever you need a low latency. Why you need low latency? You want to operate a breaker. You want to connect a car, moving car. It can't, even that millisecond delay cannot be accepted and accidents will happen. And machine to machine learning, which like real time backup you need to take between two main and backup servers. There, you know, every fraction of a second the backup server need to get the update. So wherever you are looking for a lower latency, the Leo is the best. At the same time, you look at voice. I think many people, aged people will understand. Those days, if you want to make an international call, you talk, wait, then the other man will respond, wait, again you talk. That is because all those days, the signal, voice signal was carried through geostationary satellites. So 600 millisecond, then he will respond back 600 millisecond. Voice switching takes time, etc. So with all that, it is taking a lot of time. 1 minute. Whereas with Leo, that has got considerably reduced. But the penalty what you pay, the satellite is not available to you all the time. That is the penalty you pay. How do we manage that? Put more satellites. Do the handover of traffic between one satellite to the other so seamlessly that user never feels that there is a transition. That was the challenge. So with so many mobile towers coming up, handover business has become very easy for anyone to implement. So with that, lot of new projects started coming up. I think there is other applications, so I'll come back. So again, this slide just explains you the delay factor and the distance factor. I think this is very, very clear. I don't think I need to explain. So you see, it takes 240 milliseconds one way, 240 return. Switching satellite also has got some sort of delay for switching. So 600 milliseconds for up and down. For somebody to talk 600, 1.2 seconds. After that, he will hear the voice. Then only he can respond. So what are the applications we are looking at from the Leos? All the applications. You look at any application, whichever you feel a connected car and roads and motorways, and the emergency requirement and SCADA requirement. I think people are familiar with SCADA requirement, etc. And as well as, of course, IFC, etc., is possible. So if more and more Leo satellite comes, you will get the satellite technology with lower latency. Only the issue is how many satellites to launch. Today, you are able to maintain hundreds and thousands of cell towers on the ground. That was not a challenge. Whereas now maintaining, I mean, imagine 50,000 satellites, all Leos. It is not. I'm not talking air. There is a plan. There are companies who are working. We will come back to those slides. So 50,000 satellites to be manufactured, launched, maintained into the orbit, and payloads to be maintained. Call handling has to happen between one satellite to the other satellite for the user seamlessly. And that is what is the technology which is right now available. Go back to the VSAT side, user side. User side, we always, because of microwave, all of you know, you need to have a pointed antennas. The pointed antenna should have a parabolic structure. There should be a point of focus. Feed should be kept there, like a light arrays. It will get reflected, collect the signal. This is a general theory of microwave. I think one paper itself may be there for BE students on microwave. So it's applicable for all the geostationary satellites as well as MEO satellites. When it comes to MEO satellites, a lot of efforts went and people made active phased array and passive phased array. Phased array satellites is a simple flat bed. The size is decided upon the gain of the antenna. I think isotropy gain, etc. You compare to that and decide what is the gain of the antenna. The gain of the antenna, what you need is available in active phased arrays. You do through the signal, you shift the phase and shift the frequency, and then shift the lambda and get the maximum signal. So that's another technology which LEO, only one operator has really come out of now in the globe. So that is one. And passive phased array, even ISRO started developing, and it's very costly. It's as of today, because the dielectric constant what you use need to be very, very, very low. Unless it all depends upon the dielectric constant material what you use, etc. Okay, then get into design. So the passive phased array antennas are becoming popular, and hence it is possible. The third element is you're completely avoiding a umbrella, right? That's what is the interest. And speeds, you are still able to get 400, 500 Mbps of speeds. That's more than sufficient for any consumer. The moment your phone or you put a small connection and you are getting 400, 500 Mbps speed, I don't think you will be able to match that speed in typing or viewing and understanding the data and responding it back. So here again the same principle. You need a high-end gateway and smaller terminals. So that is the technology. So basically high-end terminal, satellite, smaller equipment at the remote location. So OneWeb, which went through a lot of turbulence, they were somewhere around 75 to 800, 75 to 80 satellites on orbit. They have planned to go up to 2,000 satellites. Suddenly, after this Corona period, during this March, June period, the funder is from Japan, SoftBank, Japanese company. They are not shareholders. They invested into that. They decided to withdraw the investment. Okay, that is a very shocking news. However, the satellites were on board. Satellites are already launched. The business plan is ready, and sure the business will take off. However, they decided to withdraw. So the story doesn't end there. I'll come back. Yeah. So what is the philosophy of OneWeb? OneWeb says wherever you are, we will cover you. That is a simple principle. Their principle is where you be in the sea, you be in the forest, you be anywhere. Wherever you are, we will cover you. That means they are going to plan so many satellites, keep orbiting, and hand over from one satellite to the another is going to be so seamless. And they already have 74 satellites and 648 satellites in first phase. Now they have asked for permission for 4,800 satellites. This is some 1 week back news. Okay, after somebody has taken over. So this 4,800 satellites comes into, it's a marathon job for anyone to launch, maintain, operate, and like similar to cell tower. Now cell tower is a separate business, right? Bharti has outsourced the whole cell tower installation and maintenance to some other company type. So like that. So this is going to become a very big industry now, and India is going to get huge orders because we are capable of launching smaller satellites. All of you know we have launched 100 satellites, etc. So approximately they have kept around 1,000 to 200 kilometer orbit, and it automatically switches. The delay is somewhere around 40 milliseconds as of now, which is tested. Interesting part is for OneWeb, Hughes is manufacturing the complete remote as well as the gateway. See, really salute to Hughes where they always try to be in the forerunner of any of the technology which comes up. So Hughes has invested some shareholding as well as they develop, and hubs they are using Q and V band. Remotes are Ka band. So that means Q and V band. Till today, there are no much of the equipment, much of the technology available. Hughes has invested, and the Q and V band shipments are already happened for a few locations, and large scale shipments will start in short time to come. The good news is Bharati has acquired, along with the support from UK government, the OneWeb. This is a very big news for India because till today we have not seen any private participation in the satellite. So people make a joke. Mr. Mittal was in London during this corona and he was locked down there. And this news about SoftBank withdrawing the funding from OneWeb came out. And then he didn't have time, so he acquired this company. So it's something like that. But it's not true because Bharti already was one of the shareholder. And because Japan withdrew, the UK government, because it's a UK government support project. So UK government became active. So UK government did not want to lose out on this project. So UK government supported it, and Bharti has signed up for this. And I mean, it's very recent. It's almost 5-10 days back. So I think a lot of activity will be able to see this. And once Airtel comes at, the brand in India will be really big. So Hughes is part. Also, we also have supported, and we are also in the process of tying up with Bharti for all their research. I think that slide somewhere it will come. I'll explain. Other than OneWeb, why only I talk about OneWeb? Okay, OneWeb is definitely, we have interest on the company because Hughes is likely to be the wholesale bandwidth user in India. So the complete bandwidth of OneWeb will be used by Hughes. So we have signed up, and those deals will have renegotiate when the new promoter gets in. So if you look at similar to Leo, there are 3 projects. You just look at these projects. One is Elon Musk. All of you are aware, people who are familiar about the new development, and he is now already got into it. He paid money, he launched the satellites, and he is same concept, but because as I told you, the spectrum, orbit, etc., his Leo orbit will be around 360, 400, 500, 680 kilometers around that time. Doesn't go 1,200 kilometers. So that is his slight latency difference. It's not very big. And 540 satellites are already operational from Starlink. So when US does it, UK does it, definitely you don't expect Canada to keep quiet. So Telestat is another project started from Canada. Now similarly, Amazon always looks at where the growth is. So with Amazon also has launched another project called Gupian. Whereas Telesat and Amazon project are still little yet to get into that stage, whereas Starlink is in very advanced stage. See the news. This is yesterday's news. Starlink has already offered beta test with select users to give them 1 GB experience free of cost. The antenna size is 48 centimeter, flat panel antenna, right? And with this, what 5G can provide? I mean, I don't blame 5G. My problem is 5G is again, if the number of people go more, the frequency band is same, right? And you will again get congestion. So whereas this type of thing, it will launch another 100 satellites over because it is not any tower, it will just go on air like that. So, so this is a very big news, which now 1 Gbps is available for trials in US, of course, not in India. And yeah, so let me come back to India a little later. I'll explain about the international scenario. Well, SpaceX makes a big share on this. They have asked for 46,000 satellites. So 48,000 by OneWeb, 46,000 by SpaceX. Then Amazon is not going to left out. So I don't know how many satellites are going to get. But good part is one launch vehicle can easily carry, say, 50, 100 satellites, right? And all the launch vehicles, including Indian launch vehicles, will get busy and will get big business out of this. So already SpaceX has got US launch, OneWeb has signed up with Russian launch, like that. They are not able to go with one operator and they are taking full capacity of the launcher. That's how it operates. With all that, fine. But again, is the Geo going to be out of the scene? No. The Geo, the greatest advantage is you can still identify the beams. The new Geo HTS satellite, you are able to steer the beam. That is possible because in this satellite, you launch a LEO, you see it will be rotating. Kumbh Mela happens in India. There will be 1 lakh crowd. 1 lakh telephones have to work in that area. What will you do? STS can have a steerable beams, give the specific location required support, and the beam can be again steered back somewhere else. So what I am looking at is, it's only my perception that no technology is going to go away. SCS is continued to stay. Leo is definitely going to take the lead because machine to machine learning, as well as for low latency applications, and cost also is lower. The smaller antenna size is there. Other than big investment, I don't see anything Leo in terms of issue. And it's again computer networking. There is nothing that, other than what you really transmit to the antenna, rest all are a computer networking. So I don't see any problem with Leo going in a big way. But Geo will have to complement wherever required, and Geo has its own role to play. Yeah, now I wanted to, okay, I'll come back later. I wanted to little explain about ground segment, because the ground segments are like, definitely they are important, but all the ground segments basically are to match the satellites. Okay, so generally any operator takes one ground segment, satellite operator takes one ground segment, and he uses the specific manufacturing, specific technology, specific OEM, model numbers in general, same. They don't change, they don't operate with 4 or 5 operators. Like Cisco router can get connected to D-Link router. That's okay. But some of the specific application you have to use Cisco only. Like the similar situation here. So the ground equipments are also catching up to the requirement. In India, we have established BSNL equipment which can transmit 200 Mbps to the satellite, which can receive 200 Mbps from the satellite and transmit up to 20 Mbps. Same dish. You don't see any physical difference. Only the modem changes happen like that. So that's how the ground equipment. So I'm just giving you some vocabulary for you to understand what it is. Gateway means it interconnection with the PSDN network. When you make a telephone call, it lands through the central location and goes back to your PABX. VSATs are user terminals. Earth station moving platform is another interesting application which is coming up in India, like IFCI, internet on trains, internet requirement on big ships and boats, etc. DTS, all of you are aware. Handle terminal is something which is coming up, which will again show some interesting features there. Yes. So now come back to India, where we stand. Unfortunately, none of those applications as of now are getting coordinated or regulated or approved. It will take time. I don't say we can get isolated from the international growth. Having said that, we need time. And to best of my knowledge, ISRO doesn't have any plans to go for low Earth orbit communication satellites because they feel it is going to be very costly affair and the returns are not assured. It's a risky business. So if you see recently ISRO opened up for the private operators, so I expect there will be a big change coming out from the private operators to invest. Otherwise, as on today, there is no LEO constellations for communication is planned from India side. However, there is a regular communication business which probably can little get replaced. I won't say fully get replaced, little get replaced with fiber, etc. Is continue to drive the business in India. One is digital cinema, and other thing I listed. Let's see what is digital cinema. Digital cinema is something interesting which none of you may be fully aware of it. All of you know that earlier we used to carry reels. New movie comes from Wednesday or Friday, the reels will go across by bus, train, courier, whatever way it is. Then the new movie will get released in a limited theaters. Now you say one movie gets released, Rajinikanth movie gets released across the country with some thousands of multiplexes, right? There's no reels. It's only digital projection system where the complete movie is done on digital platform. It is being transmitted overnight because that time you get a huge bandwidth as a file, like video file, goes and sits in the projection computer, then it drives the projector system. There's a full control about number of times it can be run, when it was switched on, when it was run, etc., etc. Of course, in spite of all this, the piracy is there, but definitely it has come down very heavily. Those days, film days, the real days, it was very rampant. Now somebody goes the camera and takes the screen, you can't stop. So that's what people call camera print. Otherwise, the piracy has come down very heavily. The cost of reels, the cost of movie distribution has come down very heavily. So this is one of the things which we have pioneered not only in the US, even in India. We are the only operator who is doing digital cinema across all the multiplexes in the country. So any multiplex, you will only see our VSAT. And 99% of the theaters, even individual theaters, are connected through this system. I mean, rarely I see people taking reels. That's what is my estimation. I don't know whether in deep remote locations what's happening. So this is another e-learning application, all of you are aware, which we started, EduSat started, but somehow being government control, it did not take very well. Whereas in Maharashtra, it is a very big success. So Maharashtra, Bombay and Pune, the municipal corporations are regularly using it. And the reason could be that the whole service is outsourced. In the sense, establish, operate, maintain. It's not that we maintain. It is maintained by a company. In the sense, not government maintained. It is maintained by a company where SLA parameters are fixed, etc. And it is part of the curriculum. It is doing very well. Another major thing happening is the NEET coaching, which all of you should be knowing about it. Like MBBS coaching, you call, or PG NEET coaching, etc. All of them earlier used to send a doctor from Delhi to the respective location, and that anesthetist will come and take one day morning to evening. He will take class. Student will get bored. He will not be able to understand anything. But no choice. He keeps paying. Now that has changed. So now the central faculty does it through the e-learning. It's effective. All the operators, I mean Bhatia, DMS, and who else? I think all of them use our solution. All of them go on satellite e-learning. The advantage satellite e-learning again is once you transmit, receive across multiple locations. Even FTP, UDP, you transmit at one location. Every computer, identified computer, gets the download. If it doesn't receive it, you download once more, finished. Right? Yeah. This is a very another interesting thing in India. Reliance is one of the best examples. Reliance rolled out networks, high-speed networks across all the locations. I mean, they are not able to lay fiber everywhere. How did they roll out? So they always use a satellite backup. They put an antenna, receive the signal, connect it to the local tower, and distribute it. So this is very famous. This is called backhauls. These backhauls were earlier not so many coming up. Now the backhauls are taking up very heavily. Airtel I have not listed because Airtel has its own backhaul. BSNL has its own backhauls. We are supplying to both Vodafone, Idea, Reliance, and Airtel has become now part of us. And so many things we are doing. So backhaul also we are doing very big job. And this backhaul, naturally the disadvantage is that 275, again response another 275, 1200 millisecond delay will be there in the voice, which may be, but remote guy, he doesn't have anything, he has no choice. Whereas if Leo's coming in, that will get completely moved out. So community Wi-Fi is another application. All of you are aware that Digital India application, government used to call BharatNet, etc. They are not able to lay fiber at all the locations, maybe 20 houses, 30 houses, 100 houses location. It's not, and so many kilometers away, they are not able to do it. Very recently, they understood this, and therefore with satellite GSAT 11 coming in, they understood they will be able to give 100 Mbps speed on the download. So they got into it. Now we received at most 4 gateway orders, around 8,000 numbers of VSATs exclusively for BBNL, of course, through another PSU called TCIL. So this is another beautiful application looking at the community Wi-Fi. So see this, these are conventional. I'm not saying anything different. This where the placement happened. In this Galvan last time when this problem came, we were asked to supply a VSAT under BBNL, and it worked with complete video conferencing. People, I mean, Army is able to immediately communicate very, very effectively on this. So, how much time? Maybe half an hour, 45 minutes, you'll be able to get this setup ready. It is only the equipment should reach. The moment the equipment reaches, you have a secured communication. Nobody will be able to tap this. In addition to that, Army is putting additional encryptors this side, that side, that's okay. I'm telling you. So this is what the VSATs are. And the other side, I have shown you transportable, manually operable, fixable antenna. I mean, just anybody, I don't need any big technology, anything. Just anybody can fix it up. Each of the disaster management, battalion has got one. In Nepal, it was very famously used. And now it has made a mandatory that each of the NDR battalion will have one and sometimes 3, 4, depending upon their requirement. Now, I think we have already supplied 100, 150 numbers for this. So this is another beautiful application. and this is operational, and no time this big. I mean, it can be put in a suitcase, and you can carry it because the antenna it looks big, but you can you can disintegrate the antenna dish. Yeah. Now go a little differently. So mobile satellites, see, all we talked about putting the antenna at a stationary location. Now we are going to talk about the antenna moving. What happens when it is moving? I think if you little understand about communication, there is something called Doppler. What is Doppler? You stand here, a train goes, when it comes from far off, there will be one sound. When it comes nearby, you will have a different sound. When you go again far off, there will be a different sound, right? So the siren of it. So it's because of the frequency. There is a small frequency drift happening. Similarly, when satellite is already moving, your antenna is stationary. So you know when the satellite is moving, there is a Doppler effect. Similarly, when you start moving, you will also create a Doppler. So how do you make this Doppler compensation? So those things are inherently done in the processor. Each VSAT has got a lot of processing capability in its IDU, and the timing has to get synced up. With all that happening, there has to be a sort of advanced system on ground which can compensate this Doppler effect. Okay, so in ISRO, almost 10 years before, we tested. One of the director wanted to test this first time. 10 years before, I'm talking about. I think VTU only was a hub. What was put at engineering college. He drove from city to airport at 120 kilometers speed, and he established a VC. And he said, "I should not have any call drops." It was perfectly working. So this has become like a routine thing. So we are now then the applications possible are on internet on wheels. Like RB uses plenty of this. I mean, it's not available in public domain, but we supply that. RB uses plenty of this. Similarly, internet on railways. We did a pilot project many years before, but somehow it did not go through, and that project is still in limbo. And sat phones are best example. Handheld phone, like Inmarsat phones, etc. Then other applications are on the sea, right? Cruise needs. I mean, what is the connectivity available when you go on the sea? Nothing else. Rigs, oil rigs, cruise, boats, ships. I mean, there was no other way. You have to only depend on satellite. So, but they keep moving, and the water level changes. The azimuth elevation. You have to have 3-axis stabilization. All that is working. We are till recently, no operator can give service to maritime applications and mobile satellite applications in India. Very recently, almost say 6 months before, they've opened up, and now we are looking the customers for that. And few customers have already bought for maritime applications. And military, you can always it's being used for many years. And the third one, very important thing, is IFC. IFC is in-flight internet, right? In-flight internet, in-flight connectivity. If you see many of those flights will have, you can send an SMS, you can do WhatsApp, and if you slightly pay more, you will be able to get the voice calls also. So now how do they get it? Okay, there's a possibility that you put a tower, focus through the aircraft, and keep the towers across the flight path. This was done at some location also. I'm not saying no. This was initial days, this was done. And then they understood that is not being effective. So they moved out to satellite. So when in one flight is in one, again, you will have to look at the total solution. If a flight goes over India, and then he talks about something bad about India, India should be able to capture that traffic or voice or that signal or something. For example, some disaster happens and somebody from the flight start transmitting it back, something like that. So those type of things, it's a mandatory as per regulator to have a gateway in India. So any government is not only for India, but any government. So you should have to be able to intercept the traffic and then analyze the traffic, and if required, you should be able to block that user. So for that, any international flight coming to India, till we didn't have this permission, those flights were asked to shut down their internet connectivity. That was used to it. And even some flights which overfly, for example, they don't land in London, in Delhi. They go to London from Singapore. So those flights were asked to shut down. But how they do, they don't know. You have no control when they are on air. But that was also got resolved. Now we have a ground segment available. These traffics will go to that ground segment, and then we will be able to use. But equipment is same. Equipment is not different, but it's more of regulatory issue. But here, there is again standing over, taking over problem, like whatever we talked about LEO, because you will get into one gateway to another gateway, you will shift. Because I have a gateway in India, so we have coverage up to X location, or we are allowed to cover only up to X location. Then Gulf starts, then there is another hub which will take over. So those things are also technically working. I'm not saying possible, it's working. One problem with IFC is very difficult. You have to go through lot of certification because human network required software, hardware, power PC, etc., etc. So first you need to get FAA certificate. FAA is Federal Avionics Authority, US. So then we have to get DGSA certificate. So a lot of certification involved. And where to mount? The antenna mounting is very important, right? So that's why I just given you this small diagram. So when you mount this diagram, after this mounting, the flights have to go through, come back, lot of things have to be done. And once you get certified, then you can use only that equipment. You can't change the equipment. If you change the program, again you have to go for certification. So it's a complicated job in terms of anything electronics putting into the aviation. And one of the major challenge we faced is helicopter. Now, plane you have no problem. It's a frame space. You put a flatbed antenna, it will start looking the satellite. It's all fine. In a helicopter, there is a blade. Blade is going to block complete signals, right? It is a metal. It is chop the signal when you transmit. So for many years, there was no solution for helicopters. But Army and all the defense forces want solution for helicopters. If they have helicopters, then they can take the local video and then transmit it back to the location. They can talk, they can do many things. So there was recently, we did a demo at Bengaluru only, and Bell was front-ending, BEL was front-ending, and all the Air Force people have seen, they're very happy, and we are going to do that project also for Air Force. Internet on railways, I explained to you. I don't think it is going to start at this current situation, but technically it is possible. And many other countries it is happening. In India, it's not happening as of now. Maritime, all the vessels, they need a big data. See, the guy like a cruise, he's ready to pay any amount if he gets online internet, right? Similarly, the many vehicle, when the vessel need to be tracked where they are. And the major problem today is the smaller vessels. People go missing. They go to Sri Lanka water, they go to Pakistan water, get arrested. They don't know where they are. So all that problem gets solved with maritime services, but it is just taking off because till then it was not allowed by the military. See this picture. How many ships go across on the Indian coast where they need this connectivity? Now, because we don't have a proper setup and we did not have a proper regulatory mechanism, the ship guy is not going to switch off. He is going to get connected and he will talk to Thailand, Singapore, wherever he wants. Now that is going to get stopped. With this coming up, there will be a understanding those gateways that they are not supposed to give service. It's a very big market and very big technology. Again, you have the same doubler problem, 3-axis stabilization problem, and all that. So that all technically we have solutions which are all working today. I don't see any problem. So Indian Navy, I explained to you, it's a separate one satellite given to Indian Navy, and that has got our VSAT at ISAC as well as at Bombay. And we have got 4 hubs, C-band, Ku-band, band, anything, whichever, because they want band agnostic, and also they want to connect anywhere to anywhere we see. Somebody traveling on road will have to talk to somebody on the ship, somebody on the submarine will get connected. I mean, it's a across connectivity, across both bands, and of course redundancy, etc., etc. So one dedicated satellite project is there for Navy. This is something interesting where we have developed and it is operational in US with this satellite phone. It just, even people would have heard Inmarsat and Thuraya, we separate equipment, but little older. Now with the newer technology, there is a simple clip-on. Use your normal phone. You buy Samsung phone and use it. Just put an additional chip into that, because those phones, if they come satellite ready, put a small chip into that, and that antenna, screw it the antenna on the top. It becomes satellite ready. That means whenever the signals are not available with your local GSM operator, it switches to the satellite. So this has been proven, this has been tested, it's commercially available. And of course, when you compare the cost, naturally satellite is not that economical. So it's not as of now available for consumers. But defense forces, they are using it. The other one is add a small strip to that, connect it, and then use it. So this is also very popular internationally. Yeah. In spite of all that, there are still challenges. The technology challenges.
12:15.
We should finish another 5 minutes. So there are technology challenges. The orbit, you can't go on put LEO, HTS, all that. And where is the orbit? You are going to interfere with those satellites, right? Same satellite what OneWeb launches will interfere with Starlink, and somebody will interfere with Telesat. So that problem continue to exist, and this will be possible only through pure. It's like road traffic. So if somebody keeps a lot of traffic, then there is accidents are bound to happen if there is no discipline. So this makes people to more worry about how to grow. And currently, with all this LEO coming in for next 5 to 10 years, I don't think that problem, but definitely there is going to be orbit shortage. When the orbit shortage happens, only thing they do is go to upper band. Okay, then spectrum comes. Then today we are talking about Ka, Q and V. Q and V we never heard of. Now Q and V became synonymous hub gateways across the globe for these LEOs. So Q and V has become something popular. Similarly, new bands at higher and higher frequencies we need to go. And in terms of satellite, you put it for 10 years, 12 years, 15 years, then satellite goes out of orbit because it can't correct itself to be in that slot. What to do? Recently, they found a solution that on-orbit refueling. On-orbit refueling is something with excellent capacity. And I explained to you the BSNL satellite, which was launched around 12 years before. Now it's the end of life for another 1 year, 1.5 years. So that's what it. The guys are now running pillar to post, and now they are trying to see how to get the on-orbit fueling. Understood that they have a solution, somebody is able to do it, and already one satellite got on-orbit fueling done. With that, they are going ahead with that. So that is also another challenge which we are able to mitigate that challenge. And of course, I mean, I am only talking about satellite communication today. I'm not talking about satellite as an industry. There are so many developments happening, satellite as an industry. There's a reusable launch is coming up, and satellites itself are becoming, instead of chemicals, they are becoming electrical thrusters. There are a lot of other things are happening. I think it's a big topic if I enter into that. But what I want to tell you is, as a satellite, there is a reusable launches are coming in, which makes the cost lower, and electric propulsion coming in, then the satellite payload weight becomes increased, etc. Okay, now the satellites have huge investment. Yes, India has to spend somewhere around 800 crores on something to put on good HTS capability, right? Whereas now with LEOs coming in, the cost of individual satellite may be lower, but the numbers are very high. So it's huge capital incentive, which existing smaller companies, maybe you might not have heard Hughes, right? Maybe are not that big like Amazon or for that matter, Elon Musk, Starlink or something. So these people are now pumping a lot of money. So they are ready to Airtel for that matter. They are ready to invest on the satellite. So with big operators coming in, I'm sure this capital incentive market will see a big boost and will create a lot of job opportunities. Yes, here it is purely Ka. There is a satellite of 400 Gbps satellite, which is a regional beam, which gives spot beams across USA, North America, etc. So this is the latest is operational. Okay, so we have a long way to go from India for India. So I mean, these are all not my thoughts. You even see the ITU report. ITU report says small satellites going to get big. LEO lessons latency, and hence it is useful for machine learning. And reusable rockets will reduce the cost. And 5G ecosystem is excellently getting integrated with the satellite. That is a major advantage. So in a 5G BTS, you just insert satellite card and put an antenna, it becomes a backup. Don't need to run a fiber all the way or put your microwave tower and connect through microwave tower. And Internet of Things also explodes. So this is just to give you the overall picture in terms of how the application is developing and how it is emerging, etc. Yes, there is a tremendous effort to get the cost reduced, and more the satellite capacity, the dollar comes down and the speeds goes up, and with reusable launch vehicles, the satellite bandwidth tremendously has come down in US. It is competing with your normal home connection fiber network prices in US, because they have the high HTS capable. We are yet to get into that, and ours we have not reached the consumer. I told you. So to reach consumer, you will have to be competitive. So just big picture about what are all the developments or innovations happening on the industry, right? Digital payload technology on the satellite. What digital payload? So some beam you receive, for example, Ahmedabad beam normally does it on the west. Okay, no problem. For two beams, you don't connect to west, you connect it to Andaman. Possible. So digital payload, that is possible. Software defined satellite, I mean, I have no much idea. I think there is a lot of efforts going on. Software designed satellite is going to be probably going to get in next 5 6 years. It will become something. The requirement is you have a basic structures like you have amplifier, you have solar panel, you have power, you have stabilization system, and then you have antennas. Then do beam shaping as you need it, right? And then take the wider band and choose the band what is free and that's start. So those things should be possible. Electric propulsion, I explained to you, when the satellite is put into the specific slot, it needs to stay in that slot. Instead of staying in that slot, if there is a small disturbance, then you will not be able to see the satellite. So for that, they load the fuel when launching itself. So the fuel stock, whatever is left out available, is the life of the satellite. Instead of that, they use electric propulsion now. On-orbit fueling also explained to you, right? Another good news in India is the government has opened up the space industry to private operators. Yes, it is all going to take time, I don't deny it, but at least we see the right road to move forward. All the universities can do lot of projects with ISRO. I'm telling you, this in space which is going to come up is going to be a big thing. The chairman already talked also, and even the minister talked about it in a big way. So there is going to be a lot of university participations as well as industry participation. So already few universities are launching their own satellites. Okay, but it's again isolated. So PES has done something like that here and there. SRM has done something here and there. But now this can be done. Anybody can get into that. And remote sensing area, I have not talked at all today. That is another very big subject, very big area where universities can participate. I even suggest the university should open up a branch, remote sensing area branch or communication area branch, satellite communication area branch. Because if you look at the number of opportunities and the growth, what is going to happen in these industries, the requirement of engineers in that specialized area is going to be very, very high. Okay, so that you need to do it. And yes, satellite manufacturing, everything is getting outsourced. Even ISRO is, I mean, talking about you can launch your own vehicle, but okay, there is little too much at this stage to say about it. But somebody like Elon Musk is ready to invest. I think why not? Maybe it is possible. I mean, Reliance thinks that nothing is impossible. Yeah. So the good news or waiting for a good news is yes, we have applied for 100 Gbps private STS satellite in KA capacity. We already have a lot of interaction with ISRO, and that satellite is exclusively for India coverage. There is no other coverage, and we have documents, we have submitted, there were clarifications, all. And pending to this inspect coming up, it was all going up down, up down. Hope that with inspect getting in place and properly start getting operations, we are sure of getting the approval. And the approval happens, and it may be around 24 months to 30 months for us to have an Indian satellite, private satellite supporting STS of 100 GB. Currently, ISRO has only 40 to 50 GB capacity in pipeline. 100 GB, and we don't know, maybe we can even revamp the project and go beyond, because 200 400 Gbps are technically possible. So we can look at those options, and I'm completely not preview to what those discussions. I only can explain to you a limited information till the approval comes. Okay, so that is going to be a big news for you, of course, for a first private operator to get into launching its own satellite with fully following ISRO, DOS, DOT, WPC, ITU rules, etc., etc. I think this is my last slide, and thank you very much to one and all. I think I hope that I completed on time. Hope that it was all interesting to you. And if there is any specific queries or you need to interact with me, I think the university will share the mail ID, and I'm very happy to be here with all of you. Thank you very much.
Thank you very much, sir. That was very much informative session. There were a couple of questions which are posted there. So we will just display it on the YouTube channel now, and also
Okay.
just narrate those questions.
YouTube channel, one second. I think I'm not logged into YouTube.
You can just log in and you can see the question there on the live chat. So anyway, we'll narrate those questions. The first question is, can AI be used to stop the spread of coronavirus? I'm sorry. I'm sorry. Not that. 1 second.
Coronavirus is invisible, micron.
Not
Right.
relevant to the satellite communication. Let's ignore that. Yeah. The question is, at this point, the participant is asking, he would like to ask why downlink has higher band as compared to uplink.
No, it is reverse. The downlink means what you transmit to the satellite is higher band. What you receive from the satellite is lower bit. It's attenuation. See, any frequency, higher and higher you go, the attenuation by the atmosphere, rain, cloud, etc., are more. See, your cell phone is very low frequency. You are able to communicate on line of sight or even otherwise also. Whereas if you go to microwave, you need a pointed signal. When you go for pointed signal, then naturally you need to have lower frequency so that the attenuation can be lower, because power to be transmitted from the satellite and power to be received from the satellite, they need to be more sensitive. Here you can put a very big ground station. Even if the power is lower, you can put 10 meter, 12 meter, 50 meter antenna. So that is the reason.
Yes, sir. The second question is, what is the primary cause of signal loss in satellite communication?
It depends on the band. Every band has got different type of structure. Like I explained to you Ka band. Ka band in 2000, I joined with this company from ISRO and we did an experiment before launching, because many people told us Ka band will fail in India, because India is a sort of monsoon country, and whenever it rains, you will completely have a washout. But we understood, we tried to increase more power. So if that in C band there is no attenuation at all. I think when you understand what is C band, what is Ku band. C band is 3.7 to 4.2, 4.5, 4.8, whereas Ku band is 10.7 to 12.5, etc. So more band you go rain attenuate. Then you go to Ka band, 21 gigahertz band. Even dark clouds are going to affect the rain attenuation. Okay, so that when the dark clouds are attenuating, pump more power. So that's how you see all mitigation solutions.
Okay. Yeah. The third question is, sir, what is the approximate service life of communication satellite?
It normally depends upon how much fuel you carry. For example, in a satellite, you have two elements. One is launch vehicle, another one is satellite. Satellite carries X number of kgs of fuel. When the launch happens, after some reaching some height, launcher gets disconnected and satellite goes into the orbit. When satellite gets into the orbit, you need to fine tune and put it into the required slot. I told you, for India, it's 74.5 degrees. So you have to go and put that there. To reach that place, sometimes you use fuel, because it will start firing and chemicals will get lost. So after that, when it reaches its location, you don't need anything other than small correction here and there. Instead of shifting here, I stand stationary like this. So if I save the fuel in that place and I reach the final orbit, I gave longer life. It's all estimation. Again, I tell you, because when you are not able to measure, you have some sensor measures. But however, most of the time it is accurate. Any satellite, we normally expect 12 to 15 years.
12 to
So
15.
beyond that, you have to go and load the fuel again onto the satellite to extend another 12 to 14 years. But that problem we are going to overcome with electric propulsion coming in. That's what I explained to you. But electric propulsion is just started.
Yes, sir. Thank you. Yeah. The fourth question is, what is the reason for shifting from C band to Ku band in satellite communication?
Yeah, see, C band basically I told you, it is like frequency, right? So 3.7 gigahertz to 4.2, 500 megahertz. In 500 megahertz, 36 megahertz is one transponder. 36 megahertz, I put 40 MB or 50 MB carrier. How many carrier I put? I cannot put infinity carriers. So the band is limited. Now, same 500 megahertz, if I go to Ku, I get 10.7 to 11.5. I don't get 250. I get much more. Same 36 megahertz, I can get many slots of 36 megahertz. The total bandwidth available at higher frequencies is bigger. That is one point. The second point is C band slowly started getting into this mobile requirement. So their interference started. So the government also is making a lot of money on C band by auctioning. So they are also slowly seeing why to go for C-band. You go for Ku band, you can do it. Third element again is C-band has somehow became continental to continental because you need a bigger antenna dish. C-band lambda by 2 band, right? C is what when the frequency goes up, the size lambda comes down. So when the lambda comes down in Ku band, because it's 10 gigahertz, lambda is smaller. So the antenna when you design, you can design with 1 meter. The similar gain what you get with Ku band of 1 meter with extended or C band, for example, of 1 meter is phenomenally high. Other way I'll tell you, government regulation says minimum you have to use 1.8 meter for C band. With Ku band, you can use 1 meter. So the umbrella size is smaller. With Ka band, it is 40 centimeter. So go higher bands, the size comes down, and bandwidth you get more. And I'm sure Ku band also gets saturated. We'll go to Ka. Ku gets saturated. We'll go to Q and B. There is no choice.
Yeah.
It's not by choice.
Yes. The next question is, what is the data format of satellite images? Does it require any pre-processing?
See, it is related to remote sensing matter, or it is related to communication. I'm not clear. I'll answer communication and it can answer remote sensing also. Every operator, equipment, whatever they use, there is a proprietary. So when I transmit something, I don't transmit open like Cisco code or anything because security requirement. And the requirement is that anyhow at the other end, it is going to land on an equipment which is matching to the requirement. Right? Whereas in Cisco, you don't know who is going to receive it. Somebody will put another router. The interface need to be multi-vendor. Whereas in satellite, it is never multi-vendor. It is specific to proprietary equipment. That is for the communication. Whereas in remote sensing, satellites transmit data. Nobody should receive it and start using it for its own purpose, right? For example, Galwan area, they have taken a pictures that is being transmitted back. I can't transmit it in an open format. It has to be secure format. So the satellite, that's why it is called highly secure. The requirement is specifically to have a secure data.
Okay. So after expiry of a satellite, it becomes space debris. So how was this satellite waste or debris will be handled?
It's a really a good subject, and it needs another 1.5 hour presentation.
Okay.
It's a big problem for us. But one thing to see is you don't use 0 to 36,000 kilometer all along every 0.5 or 0.1 meter satellites. They're all predefined. If it is communication, put it 36,000 kilometer. Moment you don't put it 36,000 kilometer, say you push it down by 10 kilometer, the satellite is no more useful. It's not available to you 24/7, right?
Yes.
So as per an ITU recommendation, you should plan fuel to decommission the satellite. The word you called is decommission the satellite.
Decommissioning.
The satellite means, for example, that's why I told you calculation karo, you are going to leave another satellite is going to be another 12 years, 13 years. Then leave some fuel, ensure that it is pushed down from 36,000 kilometer to some distance, 50 kilometer, 100 kilometer down. Then it becomes debris.
Yes, yes.
Similarly, now the LEO is coming up, it is going to be a major thing for us. People are talking about 48,000 satellites, which is debris, which is satellite. So it's going to be a big challenge, but all that will be overcome. I don't think we need to too much get worried. But yes, it is a problem. It is a problem. It is being addressed. It is noted, and there is a lot of work going on how to handle the debris.
Okay. So can you please share us the IoT-based research opportunities in satellite communication? Not only IoT-based, but any kind of research opportunities in satellite communication for our organization.
Okay, I'll try to get it because Hughes does lot of job. We have tied up with, as I told you, we are tied up with Elon Musk for the OneWeb, and we have tied up with GM Motors. When how much they will be able to share it, I'm not sure. Power.
Okay.
I'll be able to sure, but I'll try. Maybe whatever is available, I can in the net, I can identify and forward it to you.
Yes, that would be really helpful for us.
Not so easily they will share.
Yeah, I know. Yes, it would be really helpful for us if you could share us those details as well. Yes, sir. So then moving on to the next question. Can we launch a satellite for our organization's requirement? So what support can we expect from your organization?
You mean Siddhganga University as it is?
Yes, it's Ganga Institute of Technology.
Yes, you can definitely look at it. There is absolutely nothing stop with the new opening up of private sector. But you
Yes.
need to define what you want. You want communication satellite. You want what is the social requirement? What you want to do depends on that.
Yes.
Absolutely. So, to start with, I would recommend. That's a long way to go.
Yeah.
Have a small project called Students Satellite. That's
Okay.
well being accepted, well being approved, and it is in practice. There is a way forward to do that, and you can make a some 100 kg satellite and call it as Swamiji's name, and then ask Antrix or NSIL to launch it. ISRO will launch it probably earlier. For some people they charge free. I don't know what is the charging mechanism, etc. But satellite manufacturing will be done in your campus.
Okay. Thank you. Yeah. Next question is when India will be 5G ready?
5G ready is not related to satellite.
Yeah.
Satellite is time ready. It is ready with respect to telecom and telco. And I'm not the right person to answer this.
Okay. Yeah. How the satellite to satellite communication happen?
Yes.
And if modem is used for that?
See, actually, this is another area which I have not completely discussed today because it is not related to commercial user requirement. It is required and it is operational. What happens is, if you see recently Gaganyaan and Mangalyaan and all got launched, and when you want to receive that signal, it is not that all the time the ground stations are visible. So you need to have a satellite which receives signal from those space vehicles and then transmit from to visible satellite and receive back. So this is operational. There is a technology available. It can be discussed, and it is very much possible.
Okay. Yeah. The next question is what are the research challenges in satellite communication?
Yeah, this is a very good question. See, that's what I told you in my initial first or second slide of the thing. You should know, first of all, little astronomy. It is about how the satellite RF behaves. Then little about computer networking because many things have become IP now. I tell you today we in a remote terminal why we are able to bring down the car. We make a chip exclusively like your mobile phone. You get a chip. We make an exclusive chip for that specific ID, specific. Only one chip will be there, remaining interface. That's all. So like that. So there is lot of that technology. So somebody can always try to select the area what you want. You need not be expert of everywhere. You can choose. Somebody can become antenna specialist where beam forming and how the get the footprints. And that can be another beautiful opportunity to develop is the flatbed antenna. Flatbed antenna is not available from any Indian manufacturer. For that matter, even the parabolic antenna is only one manufacturer in India. So these opportunities are very big. If somebody can put effort, I tried, to get one parabolic antenna developed in India. If that is going to be hot, if you make a parabolic antenna available in K band, you can put it in every vessel, every ship, every boat, right? A mobile phone sells 25,000 rupees. You sell 50,000 rupees on flatbed antenna with VSAT. People will happily buy because the necessity is there, the requirement is there.
Okay.
People can do many R&D projects on satellite communication.
Yes, sir. We would like to do that. Yeah. The next question is the last one. Can you hear us? Hello?
Yeah.
Yeah. The last question is it advantage to switch from big satellite to small satellites?
Yeah, it is really one very nice question. So we need to see other business. It is nothing to do with technology. Now technology has proven, and I told you, OneWeb has tested it, and Elon Musk says 1 GB to consumer. So technology is available. The question is business. Now the business has to see whether it is able to get that type of revenues to sustain. That is very important. So, that is a $1 billion question. People are investing so much of money. I don't think Mittal would have invested so much of money buying a defunct company or insolvent company and revive it. So, I think the business people feel there is a merit to it, and I feel with government support, if you give a lot of, it's a highly regulated industry. One problem with satellite is very, very regulated industry. India is opening. You think Elon Musk is launching man in space as a private operator.
Yes.
Whereas in India, I mean, even private satellite building is not possible. So you see the big gap. So however the government realized it and opening it up now. With that opening it up, it should be possible. I don't think it is going to be very difficult.
Okay. Some more questions are popping up. Is it okay for you to take a couple of them now?
Sure. I'm
Yes.
okay.
Yeah. When only 3 satellites can cover entire globe, why we have so many satellites? And there is any limit with respect to the orbits and such?
3 satellites can meet the connectivity from one location to the other. But the capacity, even if I put an STS, say it is 400 Gbps, if I put it also, can India itself need such a big capacity, right? I mean, there is a requirement between continent to continent connection, country connection, regional connection, and local connection. So you need so much of requirements. Football gets played somewhere in Italy, and live transmission has to happen all across the world, right?
Yeah.
Cricket happens in Pakistan or in India, so it should go back to somewhere else. So the requirement is many fold. Technically, 3 satellites will be able to connect in any location to any location in the globe.
So there is no limit as such with respect to orbits.
It is purely capacity limit.
Okay. Yeah. The last question. Can you comment on privacy issues in satellite communication?
Yeah, I say it's a very good question. I tell you. See, we have a similar equipments. What we sell to India is getting sold to some other countries also. That means if my equipment model number etc are same, how will I able to give privacy to another operator? So we have some 3 days encryption. Maybe computer science engineering students will understand. 3 days encryption is inbuilt in every IDU. So if that specific IDU is authorized to get used into that specific location of the gateway, then only that gateway will allow to open up the packets and deliver to the LAN. Otherwise, it will not. That is one connection, one point. The second point, other people want secrecy, privacy. So the best is defense. They put an additional encryptor on both the sides. ITA developed it in Bangalore for it. So that additional encryptor interface gets in, nobody can crack the. So the secrecy it is highly privacy, and nobody can tap it and see or take your voice out or anything.
Yeah. Okay. Yeah, we have one question more. Can any satellite go to Pluto?
I have no answer.
Yeah. Okay. Yeah. Thank you very much, sir. And this was really an interesting and informative session. We would like to have such a many more sessions in the future. It's really a glad and honor for us to have you with us, sir. Thank you very much. And thank you and all the participants. We look forward for you in next coming up webinar session, which is at 5 o'clock today, which is on genome engineering. The speaker is from US. So we would like to meet you all in that session next. Thank you one and all. Yes.
Thank you all of you.
Thank you, sir, once again. Yes. Okay. Dear participants, we will be sharing the feedback form now. It will be open for 1 hour. Please fill the feedback form immediately. Yeah, the form URL will be shared now. So the prospectus will be active. ನಮ್ಮಲ್ಲೇ ಮಾಡ್ತೀನಿ ಬಿಡಿ ಮಾಡ್ಬಿಟ್ಟು ಅದನ್ನ it's very interesting ನಮ್ಮ ಮಾತ್ರ